back to the lecture video on transformers in module number 3 in basic electrical engineering course. So till now we have learned about the basic principle of operation of transformer and what is its definition, what is the need of the transformer. So if you want to tell about the principle of operation, a transformer works on the principle of mutual induction. Whenever you pass an alternating current to the primary winding, it sets up an alternating flux. This alternating flux will influence the secondary winding, due to which an EMF is induced in the secondary winding. Based on the number of turns, we can define whether it is a step-up transformer or a step-down transformer or unit ratio transformer. Unit ratio transformer. If the secondary, if N2 is greater than N1, then it is a step-up transformer. If N2 is equal to N1, then it is a unit ratio transformer. If N2 is less than N1, it's a step-down transformer. So what are the induced voltages? What are the induced voltages? E1 and E2. E1 is equal to minus N into d phi by dt. And what is E2? E2 is equal to minus N2 into d phi by dt. So what is the, by dividing these two equations, we will have the transformation equation, that is given by E2 by E1 is equal to N2 by N1 is equal to I1 by I2. I1 by I2 is equal to K, where K is called as the transformation equation. And also we have learned the definition. What is the definition of a transformer? Transformer is defined as the static device which transfers electrical power from one part of the circuit to another part of the circuit without change in frequency, but with or without change in voltage levels. So this is the definition. What is the need of the transformer? The different electrical or electronic devices, or the various electrical and electronic devices, are designed for different voltage levels. To meet these voltage requirements in specific to the available voltage supply, level of voltage available voltage supply, we need transformers to meet the voltage requirements. So I have given the example of power transmission. In power transmission, we will transmit the power at very high voltage levels. So at the generation end, we need a step-up transformer. At the distribution end, we need a step-down transformer. Again, we have to step down till it reaches to the customer, because in our home, in our home or household appliances, it's only 230 volt single phase. So till that voltage level, I have to step it down and I have to receive the supply. So for this, we need transformers at different stages. So this is in regard to the power transmission. In regard to the electronic or any appliances, if you take the different electronic devices, may operate from the range of 12 volt to 24 volt. Either it may be a DC or it may be AC, even in 230 volt AC also. So to meet the requirements of voltages at for different parts and different levels of the electronic and electrical circuits, we need transformers. So these are the brief review of our last class. Now we shall go to understand the construction of transformer. We shall understand the construction of transformer. As I have mentioned already, the construction of, if I consider the construction of transformers, mainly it consists of primary winding and secondary windings. Usually the windings are made up of copper wires, low resistance copper wires. Next, if I take the magnetic core, I have already told what is magnetic core. The magnetic core provides the path for the magnetic flux. Path for the magnetic flux produced due to the current flowing in the primary winding. So what is magnetic core? It usually made up of soft iron, silicon steel material, which have low reluctance value and high permeability, low reluctance and high permeability, and which provides a smooth path for the smooth flow of the magnetic field, magnetic flux. So that is the purpose of this magnetic core. And next we need insulation of winding. Why we need insulation of the windings? So usually this winding should not get in conduction with the core. So one insulation has to provide between the windings and the core as well. In some of the usually in construction, if this is a core, say for example, if this is a core, the HV and LV winding will be concentrically wound on one above the other. So each winding with respect to core as well each winding with respect to another winding to be insulated. For that we need insulations of the windings. What are these bushings? These bushings comes into picture only in power transformer, distribution transformer, not in small capacity transformer which we use for electronic devices. Okay, this is only in big transformers which is rated above 20 kV, 50 kVA, 100 kVA, like that. For that we will use the bushings. What does it make? That bushing is a insulating material, which insulates between the tank of the transformer. Tank is what? A tank is a metal sheeted tank in which the transformer, that primary winding, secondary winding and the core, everything will be housed there. The leads means the ends of the winding. Okay, leads means ends of the winding, the primary and the secondary winding terminals. That I have to take it out and then I have to connect to the primary circuit and I have to connect to the secondary circuit, right? For that, I will take through these bushings. Without coming conduction with the tank. I have to insulate the terminals or the leads with the tank and also with the other terminals. Means total insulation I have to give. For that I will use the bushings. Okay, tank cooling arrangements. I have told the complete setup of the transformer. Like primary winding, secondary winding, core. Okay, this is the basic structure of a transformer. So all these primary winding, secondary winding, core will be housed in a metal sheeted tank. I have already told. In that metal sheeted tank, again I will come back to here for power and distribution transformers. Power and distribution transformers means very heavy duty transformers. For that transformer, we need a special kind of insulating cooling media called oil, transformer oil. So that oil is immersed in that tank and the complete setup is placed there. What is the function of the oil there? It will provide both cooling, it will act like a cooling media, transformer cooling will be done, and also it will provide the insulation. In most of the low capacity transformer, no oil will not be there. So that is air cooled transformers. Very small transformers you can see 230 volt bar, 24 volt single phase transformer. There is no need of oil and all. So not much cooling or insulating medium is needed. So here for heavy transformers we need oil. These are the different parts of the transformer. Okay. Now how constructionally it will look like. Okay. Constructionally it will look like. There are two type of transformers based on the construction. The transformers are classified into two types based on the construction. That is core type transformer and shell type transformer. So in core type transformer, the core, say for example this is a core. So this is a silicon steel laminated core. So So this is the winding. So this is the winding. This is the path of the flux. Path of the flux. Say this is phi, and this is primary winding leads. This is what is lead. Primary winding leads, and this is secondary winding lead. So this is V1 and this is V2. Okay, V2. This is N1, this is N2. This is induced EMF E1 and this is induced EMF E2. E2. Okay, so here what you can observe is some considerable portion of the core is surrounded by what? Considerable portion of core is surrounded by winding. But in shell type transformer, here there will be primary and secondary, both will be there. This is primary terminal and this is secondary terminal, and this is the total core. Okay, this is the total core. I will rewrite it once again, otherwise you will get confused. Rewrite this once again. Okay, this is core type transformer. Okay, like this is actually the core. Okay, now this windings will be here. Okay, windings will be here. So this is HV and this is LV. LV and HV means high voltage and low voltage. So this is one end terminal and this is one end terminal. Here the considerable portion of the windings are surrounded by the core. Okay. So this is shell type transformer. This shell type transformer is used for high voltage transformer. This core type is used for low and medium voltage transformer. High voltage means above, if the transformer is voltage level is rated for 66 kV, 33 kV, 110 kV, like this. What is low and medium voltage? Usually 230 bar 24 volt single phase transformer, 440 bar 3 phase transformer, 440 bar 220 3 phase transformer, 11 kV bar 440 3 phase transformer. Like this, the for low and medium voltage transformers we will be using core type construction. In the core type construction, usually, as I said earlier, the high voltage and low voltage windings are concentrically wounded on one another and insulated to each other. Not exactly specifically like this. Primary HV winding will be here, LV winding will be here, not on the two limbs exactly. The two limbs on one limb itself you can find HV and LV winding concentrically, here also. Usually, why we do that? To avoid the leakage flux. There will be leakage flux. To avoid the leakage flux, we will do like that in the construction. We shall not go deep into it. It is not in this up to the scope of your syllabus. Okay, so this is enough. So constructionally, we have two type of transformer, that is core type transformer and shell type transformer. So core type will be used for low and medium voltage, and shell type will be used for high voltages, very high voltages. So this is core type and shell type transformer. Now, how the magnetic core is made of? So if in examination, if a question appear like explain the construction of a transformer, you have to explain core, windings. Mainly you have to explain core and windings. Those are the two. Additionally, you can explain that bushings, tank, cooling, all those things. Okay, now I will explain the core. Usually the magnetic core is made up of, again I have told, is made up of silicon steel laminations. Why these silicon steel laminations are made? Example, I will tell with an illustration. Say for example, it is one limb of the core. If you apply voltage here, the current will pass through it. If you apply voltage here, in general, any magnetic core material, if you apply voltage here, the current will pass through it. Due to the current pass through it here, what will happen? Due to the alternating current, alternating flux will produce. The same alternating flux will produce an EMF across it. So this is usually it will be in the, if the windings are there, means number of turns is more, then the effect of this EMF is more. If the number of turns are very less, the induced EMF amount will be very less. So in general, I will give this background. Okay, now we will come back to the transformer core. I told it is made up of silicon steel lamination. If this core will have this windings, right? This windings. So due to the current applied here, it sets up a magnetic flux phi, right? This magnetic flux. When this magnetic core is subjected to a cycle of magnetization means the flux will be like this. Now it is also alternating in nature. So due to this flux, in one half cycle it will be magnetized in one direction. In another half cycle it will be magnetized in another direction. Means it will become north and south. In another half cycle it will become north and south. Cycle of magnetization. So if you apply the cycle of magnetization, what will happen? This flux also changes with respect to time. When this flux changes with respect to time and it is not unidirectional, what will happen? A small EMF E is induced here in the core itself. Due to this small EMF, current will flow through this. The core. This current is called as eddy currents. EDDYCURRENTS. Eddy currents. So this current is called as eddy current. What is eddy current? Due to the alternating flux, a small amount of current also flow through the core also. Due to which an EMF, and a voltage, an EMF is, a small amount of EMF is induced in the core also, due to which a current will flow through this. Due to the current flowing through this and due to the resistance of the core, if I is the eddy current, small eddy current that is flowing through this, and R is the resistance, I square R is the eddy current loss. Power formula is what? I square into R. If capital letter R is the resistance offered by this core, then I square R is the eddy current. So now you can understand if the area is too high, if a block of iron is used, if a block of iron material is used, then what will happen? The area is higher. Then what is resistance? Resistance is equal to rho into L by A. What is rho? Resistivity. If area is higher, what is resistance? Resistance is lower. Since resistance is lower, current will be higher. So the magnitude of the eddy current will be higher. If I use a thick limb of what I can say, block of an iron, block of an iron or a block of a iron material as the core material, the current I will increases, due to which I square R loss will be more, due to which I square R means the eddy current loss will be higher. Eddy current, not I square R loss. You should not call that I square R loss. Usually we call I square R as copper loss. Don't get confused here. Eddy current loss will be higher due to the current is higher. Okay. So for that, what I will do, I have my intention is to reduce the eddy current in the core. Intention is to reduce the eddy current in the core. For that, what I have to do, I have to reduce the area so that it will increase the resistance, so that it will decrease the current. When the current decreases, eddy current, amount of eddy current decreases, what will happen? Amount of eddy current decreases, what will happen? The total eddy current loss decreases. So to reduce the area, what we will do, we will use laminations. We will use lamination. Which lamination? Silicon steel lamination. This silicon steel will provide very low reluctance path. Reluctance means what? Opposition to the magnetic field or the magnetic flux. Opposition offered by the material to the path of the magnetic field. So if it is low reluctance, the magnetic field will be easily flown, or it gives a resistant frictionless or resistant free path for the magnetic field. So we will use silicon steel laminations. Why we use lamination? To reduce the area. For that, I will use like this: one strip, another strip, another strip, another strip, and all are staggered and varnished. Staggered and varnished. Varnished means some chemical that will give varnishing, that will improve the characteristic, good characteristic of a magnetic core. And also staggered means it's a mechanical term like welding and all. This will be staggered. So you can imagine this is a scale. You have seen a scale. One scale, another scale, another scale, one more scale on it. That will be staggered. That will become a lamination. One scale is also, each scale is made up of silicon steels. Silicon steel. All are staggered. All are staggered to form silicon steel lamination. All are staggered to form silicon steel lamination. Why I have done like this lamination? To reduce the area. Instead of using a block of iron, I am using laminations that reduces the area, that increases the resistance, that decreases the eddy current. So ultimately, what is the moral of the story is, by using silicon steel lamination, we can reduce the eddy current loss. So we can summarize the overall essence like this: the magnetic core is made up of silicon steel laminations to reduce the eddy current loss. What is eddy current loss? Eddy currents are the currents which is flowing in the core itself due to the small amount of EMF induced in it. So to reduce the amount of eddy current, we are using a laminated core, or we are using a laminations that reduces the area, due to which the amount of eddy current will be reduced. That is the overall essence. Okay, summary of this magnetic core. You have to write all these things for the magnetic core. Next, for the windings, it will have primary winding and secondary winding. It will have, it is made up of copper. It is made up of copper and low resistance copper. And next, you have to use tank, cooling material, those things. Yeah, I have told. Oil for high heavy duty transformers like power and distribution transformers, tank will be a metal sheeted tank will be used. In that metal sheeted tank, the overall transformer setup, the core and winding setup will be immersed in a oil. That oil will produce gives both cooling as well insulating that will provide both cooling and insulation. Those things you can write. This is regarding the construction, and constructionally it has both core type and shell type transformer. So these things you have understood. Now you have understood the construction. Now you have understood the construction. In the next video we shall understand, we are going to learn about EMF equation. EMF equation of a transformer. Equation of transformer. In the next video we are going to learn about EMF equation of a transformer. Thank you.